arithmetic progression and geometric progression. Dear students, you must have seen different patterns in the nature. For example, petals of a sunflower, then leaves of a Christmas tree. Also, there is a definite pattern of design on your dress or a sari, isn't it? This looks beautiful. So, in this chapter, we are going to study patterns in numbers. Now consider the list of numbers given here. That is 1, 3, 5, 7, 9, ... So what pattern you have observed here? Yes, the difference in every successive number is 2. That means we get every successive number by adding 2 to the previous number. So naturally, the next number in this series will be 9 plus 2, that is 11. Next one will be 11 plus 2, that is 13, and so on. Now consider this another list. 1, 4, 9, 16, ... So what pattern is there? Here, each number is a square. So the first one is square of 1. Second one is square of 2. Third one is square of 3, and like that. So naturally, the next number in this series will be square of 5, that is 25. Next one will be square of 6, that is 36, and so on. That means there is a definite pattern. So, now we'll know what is meant by a sequence. A sequence is a collection of numbers arranged in a definite order according to some definite rule. So, each number in the sequence is called a term of the sequence. The number in the first position is the first term and is denoted by T1. The number in the second position is the second term and is denoted by T2. Next one will be T3. In general, the number in the nth position is the nth term and is denoted by Tn. A sequence is usually denoted by Tn in curly bracket and it is read as sequence Tn. So, in the given sequence 1, 5, 9, 13, T1 is equal to 1, T2 is equal to 5, T3 is equal to 9, and so on. So now we'll find out the sum of the first n terms of a sequence. If Tn is the sequence, we denote the sum of the first n terms of this sequence by Sn is equal to T1 plus T2 plus T3 plus ... plus T1. Here, S1 is T1, S2 is T1 plus T2, and so on. And therefore, Sn is equal to T1 plus T2 plus T3 plus ... plus Tn. And therefore, Sn minus Sn minus 1 is equal to Tn. And therefore, Tn is equal to Sn minus Sn minus 1. So now, we'll know about the types of the sequences. If the number of terms in a sequence is finite, then it is a finite sequence, or otherwise it is infinite sequence. So now the question is, for the given sequence, find the next 4 terms. 3, 9, 27, 81, ... Here, first we'll find out the difference. 9 minus 3 is 6. 27 minus 9 is 18. That means this is not the pattern. So now if we multiplied 3 by 3, then you get 9. That is the next term. If you multiplied 9 by 3, you get the next term. So this is the pattern. So now 3 into 3 is equal to 9. 9 into 3 is equal to 27. 27 into 3 is equal to 81. So 81 into 3 is 243. 243 into 3 is 729. 729 into 3 is 2187. And 2187 into 3 is 6561. Now the next sequence. 2, 6, 12, 20, 30, ... Now the difference of 2 and 6 is 4. The difference in 6 and 12 is 6. The difference in 12 and 20 is 8. That means the difference in the consecutive terms is getting increased by 2. And therefore, the difference in 20 and 30 must be of 10. So, the next term must be 30 plus 12, that is 42. Next will be 42 plus 14, 56. Next one, 56 plus 16, 72. And next one, 72 plus 18 is 90. Next question. Find the first 5 terms of the given sequence whose nth term is given. So Tn is equal to 2n minus 5. So when n is equal to 1, T1 is equal to 2 into 1 minus 5, that is equal to 2 minus 5, that is equal to minus 3. Then for n is equal to 2, T2 is equal to 2 into 2 minus 5, that is equal to 4 minus 5, that is equal to minus 1. When n is equal to 3, T3 is equal to 2 into 3 minus 5, that is 6 minus 5, that is equal to 1. When n is equal to 4, T4 is equal to 2 into 4 minus 5, that is 8 minus 5, that is equal to 3. And when n is equal to 5, T5 is equal to 2 into 5 minus 5, that is 10 minus 5, that is equal to 5. So the first 5 terms are minus 3, minus 1, 1, 3, 5. Next question. Find the first 3 terms of the given sequence for which Sn is equal to n square into bracket n plus 1 the whole square upon 4. Therefore, S1 is equal to 1 square into bracket 1 plus 1 the whole square upon 4. That is equal to 1 into 4 upon 4, that is equal to 4 upon 4, that is equal to 1, that is equal to T1. Then S2 is equal to 2 square into 2 plus 1 the whole square upon 4, that is equal to 4 into 9 upon 4, that is equal to 9. Now T2 is equal to S2 minus S1, that is equal to 9 minus 1, that is equal to 8. Then S3 is equal to 3 square into 3 plus 1 the whole square upon 4, that is equal to 9 into 16 upon 4, that is equal to 36. Now T3 is equal to S3 minus S2, that is equal to 36 minus 8, that is equal to 28. And therefore, the first three terms of the given sequence are 1, 8, 28. After the sequence, we'll see what is meant by progression. A progression is a special type of sequence in which the relationship between any two consecutive terms is the same. Now, the first type of the progression is arithmetic progression. Arithmetic progression, that is AP, is the sequence such that given a first term, each term is obtained by adding a fixed number to the preceding term, and this fixed number is called the common difference and is denoted by D. That means AP is a sequence in which the difference between two consecutive terms is constant. The value of D may be positive, negative or 0. And if t n plus 1 minus tn is constant, then for every natural number the sequence is an AP. Now if you want to represent AP, then generally we can say that T1 is equal to A. So T2 is equal to T1 plus D, where D is the common difference, that is equal to A plus D, that is equal to A plus 2 minus 1 D. If T3 is taken, T3 is equal to T2 plus D, that means T1 plus 2D, that means A plus 3 minus 1 into D. So, in general we can say Tn is equal to A plus n minus 1 into D. So now, look at the given list of number and say whether it is arithmetic progression or not. 3, 6, 12, 24. Here, A is equal to 3. Now 6 minus 3, that is T2 minus T1 is equal to 3. Then 12 minus 6, that is T3 minus T2 is equal to 6. So here T is not constant and therefore it is not AP. Now the question, find the 18th term of the AP 1, 7, 13, 19. Here A is equal to 1 and D is equal to 7 minus 1, that is equal to 6. Also we confirm 13 minus 7, that is equal to 6. Now Tn is equal to A plus n minus 1 into D. Therefore T18 is equal to A plus 18 minus 1 into D, that is equal to A plus 17D. Putting the values, T18 is equal to 1 plus 17 into 6, that is equal to 1 plus 102, that is equal to 103. Now we'll see the formula to find out the sum of first n terms of an AP. So Sn is equal to n upon 2 into bracket 2a plus n minus 1 into d. But if we know the first term and the nth term of the AP, then we can modify this formula as Sn is equal to n upon 2 into a plus L, where a is the first term and L is the last term of the AP. So now the question is, find the sum of all numbers from 1 to 140 which are divisible by 4. Now the numbers divisible by 4 from 1 to 140 are 4, 8, 12, 16, dot 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 140. Here A is equal to 4, D is equal to 4 and AN is equal to 140. We know that AN is equal to A plus N minus 1 into D. Therefore, 140 is equal to 4 plus N minus 1 into 4. So 140 is equal to 4 plus 4N minus 4. Therefore 140 is equal to 4N and N is equal to 140 upon 4, that is equal to 35. That means there are 35 multiples. So Sn is equal to N upon 2 into bracket 2A plus N minus 1 into D. Therefore S35 is equal to 35 upon 2 into bracket 2 into 4 plus 35 minus 1 into 4. That is equal to 35 upon 2 into bracket 8 plus 34 into 4. That is equal to 35 upon 2 into bracket 8 plus 136. That is equal to 35 upon 2 into 144. That is equal to 35 into 72. That is equal to 2520. Next question. Find 4 consecutive terms in an AP whose sum is 12 and the sum of third and fourth term is 14. When we solve such type of problems, whenever we wish to consider 3, 4 or 5 consecutive terms of an AP, it is convenient to consider them as this. 3 consecutive terms, then they should be A minus D, A and A plus D. If 4 consecutive terms are there, then A minus 3D, A minus D, A plus D, A plus 3D, like that. So, in this problem, let the 4 consecutive terms be A minus 3D, A minus D, A plus D, A plus 3D. And their sum is given as 12. And therefore, A minus 3D plus A minus D plus A plus D plus A plus 3D is equal to 12. Therefore, 4A is equal to 12 and A is equal to 3. Now, the sum of third and fourth term is 14. That means A plus D plus A plus 3D is equal to 14. So 2A plus 4D is equal to 14. Therefore 2 into bracket A plus 2D is equal to 14. Therefore A plus 2D is equal to 7. But A is equal to 3 from 1. And therefore 3 plus 2D is equal to 7. So 2D is equal to 4. Therefore D is equal to 2. And therefore the AP is A minus 3D, that is equal to 3 minus 3 into 2, that is equal to 3 minus 6 is equal to minus 3. A minus D is equal to 3 minus 2, that is equal to 1. A plus D is equal to 3 plus 2, that is 5. And A plus 3D is 3 plus 3 into 2, that is 3 plus 6, that is 9. So the AP is minus 3, 1, 5, 9. Now we'll see one word problem. A meeting hall has 20 seats in the first row, 24 seats in the second row, 28 seats in the third row, and so on, and has in all 30 rows. How many seats are there in the meeting hall? The number of seats in the rows are 20, 24, 28, dot dot dot. That means A is equal to 20 and D is equal to 24 minus 20, that is 4. There are in all 30 rows, therefore Sn is equal to n upon 2 into bracket 2A plus n minus 1 into D. So S30 is equal to 30 upon 2 into bracket 2 into 20 plus 30 minus 1 into 4. That is equal to 15 into bracket 40 plus 29 into 4, that is equal to 15 into bracket 40 plus 116, that is equal to 15 into 156, that is equal to 2340. So, there are 2340 seats in the meeting hall. After arithmetic progression, now we'll see the another type, that is geometric progression GP. T2 upon T1 is equal to R, T3 upon T2 is equal to R, T4 upon T3 is equal to R dot dot dot, Tn upon Tn minus 1 is equal to R, then it is a geometric progression. But remember, since division by 0 is not permissible, neither the common ratio nor any term of a GP can be 0. So the general representation of a GP is A, AR, AR square, AR cube, dot dot dot, where A is the first term and R is the common ratio. Therefore, Tn is equal to A into R raised to n minus 1. Now, this is the formula to find out the sum of the first n terms of a geometric progression. Therefore, Sn is equal to A into bracket 1 minus R raised to n upon 1 minus R if R is less than 1. And if R is greater than 1, this is written as Sn is equal to A into bracket R raised to n minus 1 upon R minus 1. So now, if S3 is equal to 31 and S6 is equal to 3906, find A and R. Here S3 is equal to 31 and S6 is equal to 3906. Sn is equal to A into bracket R raised to n minus 1 upon R minus 1. So S3 is equal to A into bracket R raised to 3 minus 1 upon R minus 1. So 31 is equal to A into bracket R raised to 3 minus 1 upon R minus 1, equation 1. Similarly, S6 is 3906, therefore 3906 is equal to A into bracket R raised to 6 minus 1 upon R minus 1, equation 2. Now we'll divide equation 2 by equation 1. So, A into bracket R raised to 6 minus 1 upon R minus 1 divided by A into bracket R raised to 3 minus 1 upon R minus 1, that is equal to 3906 upon 31. Therefore, R raised to 6 minus 1 upon R cube minus 1, that is equal to 3906 upon 31. So, R raised to 3 raised to 2 minus 1 raised to 2 upon R raised to 3 minus 1, that is equal to 3906 upon 31. Therefore, R raised to 3 minus 1 in one bracket into R raised to 3 plus 1 into another bracket divided by R raised to 3 minus 1, that is equal to 126. Therefore, R raised to 3 plus 1 is equal to 126. Therefore, R cube is equal to 126 minus 1. Therefore, taking the cube root of both sides, R is equal to 5. Substituting the value in equation 1, we get 31 is equal to A into bracket 125 minus 1 upon 5 minus 1. Therefore, 31 is equal to A into 124 upon 4. Therefore, 31 is equal to A into 31. Therefore, A is equal to 1. So, A is equal to 1 and r is equal to 5. Now, after these, whenever we want to find out a particular term in GP, then it is convenient to consider the consecutive 3, 4 or 5 terms like this. If 3 consecutive terms are there, they should be A upon R, A and AR. If 4 consecutive terms are there, they should be A upon R cube, A upon R, AR and AR cube like this. Now we'll see how to find out the arithmetic mean of X and Y. So arithmetic mean A is equal to X plus Y upon 2. The geometric mean G is equal to plus or minus under root X into Y.